Look around. Our entire world is held together by steel. Every skyscraper, cargo ship, and car relies on it. We forge 2 billion tons a year, but steel has a dirty secret. Making it releases 9% of global emissions, more than all cars combined. Engineers thought that pollution was just the price of progress. Until now. Scientists in China have perfected a crazy new material. It's lighter than aluminum, flexible and stronger than steel, without needing a single blast furnace. Experts called it impossible, but now a global race is on. Subscribe right now, because you won't want to miss how this changes everything. To understand why this new material is completely shocking the industry, you first have to realize why trying to replace steel has been a fool's errand for over a century. It's not because scientists weren't trying. It's because steel is an absolute miracle of engineering. It handles immense tension, meaning you can pull and stretch it, and it won't snap. It handles massive compression, meaning you can pile millions of tons of concrete on top of it, and it won't crush. Plus, unlike carbon fiber or advanced ceramics, steel can be melted down, recycled, and reused indefinitely without ever losing its strength. For generations, our entire global supply chain has been perfectly optimized for it. Shipping containers are built for steel frames. Factory robots are calibrated specifically for the melting point of steel. The entire global economy runs on the exact assumption that if you need to build something heavy, durable, and permanent, steel is your only real option. The true problem isn't how steel behaves after it's made, though. The problem is baked directly into the chemistry of how iron atoms bond. To get pure iron out of natural rock, you have to rip oxygen atoms away from the iron molecules. The only cheap, effective way to do that at a massive scale is to use carbon. Think about that for a second. Even if we powered every single steel mill on Earth with 100% clean solar and wind energy, the chemical reaction itself still forces massive amounts of carbon dioxide into the sky. Pollution isn't a side effect of using dirty energy. It is literally a requirement of the recipe. The question nobody was asking was radically simple. What if the replacement for steel isn't a metal at all? So, how do you actually beat steel? A research coalition in China decided the only way forward was to abandon metals entirely. Instead of fighting steel's inherent chemistry, they built something completely new, a structural carbon lattice matrix infused with a dense, crystalline polymer. Think of it as taking the molecular strength of a diamond and weaving it into a flexible, microscopic fabric. Now, usually, when engineers try to make a material this light, it becomes brittle. It can hold a load, but the moment you hit it with a hammer, it shatters like glass. The Chinese team solved this at the nanometer level. Using an advanced deposition process, they forced carbon atoms to lock into a repeating, honeycomb-like geometry under massive electromagnetic pressure. What came out of the chamber surprised even the researchers. When they ran the structural tests, the material displayed a strength-to-weight ratio 5 times higher than structural steel. In practical terms, this means you could build a bridge using 80% less mass, and it would still handle the exact same weight. But the real magic happens at the atomic level. In standard metal, stress creates tiny, invisible imperfections that act like cracks, eventually leading to metal fatigue and catastrophic failure. In this new lattice, those cracks have nowhere to go. The structure dynamically absorbs and redistributes force across the entire matrix. It doesn't rust, it ignores saltwater corrosion, and it holds its strength at temperatures that would make standard steel soften and sag. The detail that truly shocked the global industry. They achieved this using abundant, everyday organic compounds. They didn't need rare earth minerals or massive, planet-cooking blast furnaces. They simply rearranged the building blocks of nature. It is, quite simply, a fundamentally superior product that changes everything. In the world of material science, news usually moves at a snail's pace. Safety boards can take a decade just to approve a new type of bolt. let alone a completely new structural material. The stakes are simply too high. If a material fails, people die. So when industrial giants across the West and Asia started filing emergency patents within months of this Chinese research leaking, it was a massive wake-up call. This wasn't just another boring academic paper. It was a seismic shift. Engineering firms in Germany and Japan are already racing to build their own versions. And let's be clear, they aren't doing this out of environmental idealism. It's pure math. In a global market where shipping costs are dictated by weight, imagine cutting the mass of a cargo ship or a freight train completely in half without losing an ounce of durability. That means saving millions of dollars in fuel on every single trip. In any industry, cutting your weight while multiplying your strength isn't a trend. It is a brutal competitive advantage. If you don't adapt, your rivals will put you out of business. It's that simple. Best of all, this isn't just theoretical hype. Real-world validation has already hit the ground. In a pilot logistics project in southern China, engineers installed support columns made from this new composite inside a high-stress heavy rail corridor. For 12 solid months, embedded ultrasonic sensors monitored those columns under the crushing weight of thousands of passing freight trains. The results? Zero structural degradation, zero microfractures. The real-world data matched the lab predictions perfectly. The technology now has receipts. The potential scale of this is almost hard to wrap your head around. Life cycle models show that replacing just 15% of global structural steel with this new composite would cut more carbon emissions than the entire industrial footprint of Western Europe. Think about that. One single material swap could out-impact an entire continent's worth of factories, power plants, and heavy industry. But taking a miracle from a lab and turning it into a global standard is a long, brutal road. And honestly, the biggest roadblock isn't the material itself, it's the fact that the entire world was built for steel. Right now, millions of factories across the globe are optimized exclusively to melt, cut, weld, and stamp metal. This new composite changes all the rules. It requires completely different tooling, new automated bonding techniques, and massive workforce retraining. For manufacturing hubs in developing economies, the upfront cost to tear down old assembly lines and retrofit these factories is a massive financial barrier. So while China has proven the science, the rest of the world now faces a high-stakes choice: invest billions to rebuild our industrial backbone, or risk getting left behind entirely. The scientists gave us the ultimate tool, but whether the global market can pivot fast enough to actually use it is a different question. One thing is certain: the era of relying solely on heavy, dirty iron ore is drawing to a close. Now I want to hear from you. If an everyday material like steel can get a revolutionary upgrade like this, it makes you wonder what else we are missing. What other common material is hiding a massive breakthrough right in plain sight? Drop your thoughts in the comments, and I'll see you in the next video.